In this video, let us solve a couple of challenging trigonometric identity questions. So here we have to prove cosecant x minus sin x. We have been given the information that it is a cube and secant x minus cos x is equal to b cube. Then we have to prove that a square b square times a square plus b square is equal to 1. So this is one equation we have to solve. Second is cot x times 1 plus sin x is equal to 4m and cot x times 1 minus sin x is 4n. Then we have to prove that m square minus n square, the whole square, is equal to mn. So let's try to address these problems. I would suggest that you pause the video and try it out yourself. And if you're liking this channel, please share these videos with your friends and also subscribe. So now please pause the video and try it out yourself. I'll see you in a minute. Okay, now let's try to find the first proof. So the information given to us is cosecant x minus sin x is a cube and secant x minus cos x is b cube. We have to prove that a square b square times a square plus b square, this will result to 1. So here, before we start the proof, we have to find the individual value of a and b. So once we find that out, what a and b are, then we can apply it in this equation. So let's do that first. So the first information is cosecant x minus sin x is equal to a cube. So we have 1 by sin x minus sin x is equal to a cube. So 1 minus sin square x by sin x is equal to a cube. So 1 minus sin square x is cos square x because of the identity which we have, cos square x plus sin square x is equal to 1. So let's apply that. So 1 minus sin square x is cos square x by, now the denominator is sin x, this is a cube. So if this is a cube, what would a be? A would be equal to the cube root of this one. So cos square x by sin x to the power of 1 by 3. Basically we are looking for the cube root of this. So this is what we have. So let us consider this the solution for a. Now similar way, let's use the second data we have, secant x minus cos x is equal to b cube, and find out the value of b. So this would be secant x minus cos x is equal to b cube. So 1 by cos x minus cos x is equal to b cube, 1 minus cos square x by cos x is equal to b cube. Now 1 minus cos square x can be replaced by sin square x because of the identity, and the denominator is cos x. This is equal to b cube. So now b would be equal to cube root of this part. So b is sin square x by cos x to the power of 1 by 3. So now we know a and b individually. Now we just have to apply these values in this a square b square and a square plus b square equal to 1. So that is what we have to apply. Now let's write it down. So the thing we need is a square b square times a square plus b square, correct? So let's start applying a and b values individually. So we would have a square would be cos square x by sin x, correct? This would be to the power of 2 by 3 because it is a square, times sin square x by cos x to the power of 2 by 3, and the inner part would be a square again, which is nothing but cos square x by sin x to the power of 2 by 3 plus sine square x by cos x to the power of 2 by 3. So why did we have 2 by 3 here is because it is square. So if you know the rules of exponents, this would change to 2 by 3. Now let's start solving this. We would have, so if you notice here, the 2 by 3 there is cos and sine both in the denominator. So there is a chance that we can cancel out few things in the numerator, correct? Now what we can do is, by cancelling out, we would get sin x times cos x to the power of 2 by 3, because one of the sin x 2 by 3, one of it gets cancelled. Only we will remain with only one in the denominator, which is sin x times cos x to the power of 2 by 3. And the second part of the equation would be cos square x to the power of 2 by 3 divided by sin x to the power of 2 by 3 plus sin square x to the power of 2 by 3 by cos x to the power of 2 by 3. So basically I applied this exponents to numerator and denominator separately. Now what we can do is, let's solve for the common denominator or rationalize the denominator here. So we are both multiplying sin x and cos x towards sin x 2 by 3 and cos x 2 by 3 to numerator and denominator. Let's do that now. So now the equation would be sin x times cos x to the power of 2 by 3 times, now cos x to the power of 2 by 3 times cos square x to the power of 2 by 3. So this will change to cos cube x to the power of 2 by 3 plus sin cube x to the power of 2 by 3 divided by sin x to the power of 2 by 3 times cos x to the power of 2 by 3. Now if we see here, this part of the equation gets cancelled. Now we know the rule of exponent that a to the power of x to the power of 1 by x is equal to a. So here the cube root and the cube gets cancelled. Same way it applies here too. So we will have cos square x plus sin square x, which is equal to 1. So this is how we arrived at the proof that a square b square times a square plus b square is equal to 1. So we individually found the value of a and b, and then it is just solving the exponents. So please practice such problems so that you are well versed with application of exponents as well as algebraic equations. So please share the video with your friends so that it's helpful to them too. Thank you for watching. I'll see you in the next video. Let's solve the second problem now. Here we have been given two information, which is cot x times 1 plus sin x is equal to 4m, and cot x times 1 minus sin x is 4n. Now using this information, we have to prove that m square minus n square, the whole square, is equal to mn. So we see that there is m square and n square as well as a multiplication between m and n. So we can achieve this by squaring the given data. So m square can be achieved by squaring this part of the problem, and n square can be achieved by squaring the second part of the problem. So let's square them. So we would get cot square x times 1 plus sin x the whole square is equal to 16m square, and the second part of the equation we would get cot square x times 1 minus sin x the whole square is equal to 16 n square. Now we have m square minus n square. So let's subtract these two. We would get cot square x 1 plus sin x the whole square minus cot square x 1 minus sin x the whole square is equal to 16 m square minus 16 n square. Now let's try to solve this equation. So we would get cot square x times 1 plus sin square x plus 2 sin x. I just applied a plus b the whole square, and minus cot square x times 1 plus sin square x minus 2 sin x. Just a minute, let me fix that. Minus 2 sin x is equal to 16 m square minus 16 n square. Now let's solve this. This would be cot square x plus sin square x cot square x plus 2 sin x cot square x minus cot square x minus sin square x cot square x, and this would be plus 2 sin x cot square x is equal to 16 m square minus 16 n square. Okay, now let's see what can be cancelled out. So we can cancel out the cot square x, then we can cancel out sin square x cot square x. So we will have 4 sin x cot square x is equal to 16 m square n square. Correct? Now we can cancel 4 and 16. It is divisible. Sorry, this is not m square n square. It is m square minus n square. Let me fix that. Okay. So what would the value be of m square minus n square? Is equal to sin x times cot square x divided by 4. So we know m square minus n square now. So let's hold this for now. So this is first part of the equation. Okay. Now we have to achieve m times n. So what we can do is, let's multiply these two parts of the data so that we get m times n. So what would that be? If we multiply, we would get cot x times 1 plus sin x multiplied by cot x times 1 minus sin x is equal to 4m multiplied by 4n. So I just multiplied these two information that was given in the question. Now if you notice, this will be a plus b, a minus b. So we can change this to cot square x into cot x, and this will be a square minus b square is equal to 16 times mn. Now 1 minus sin square x is cos square x. We can replace this with cos square x. So we will have cot square x times cos square x is equal to 16 times mn. So mn is equal to, let's change cot x to cos x by sin x. We will have cos to the power of 4x by sin square x. Sorry, 16mn is equal to. So mn is equal to cos to the power of 4x by 16 times, 16 times sin square x. Now we know mn and m square minus n square, but the required thing is m square minus n square the whole square. So what would that be? M square minus n square the whole square. So we just have to square this part. We will have sin square x times cot to the power of 4x divided by 16. Now if we solve for cot, we can change it to cos by sin. So this will be sin square x times cos to the power of 4x by sin to the power of 4x divided by 16. We can cancel out the squares. So we would have cos to the power of 4x by 16 times sin to the power sin square x. So mn and m square minus n square the whole square, these both are equal. So this is how we can prove the second problem. If you like this channel, please share it with your friends so that trigonometry becomes easy to them as well. Thank you so much for watching. I'll see you in the next video.